Hello, this is Dr. Hanaa Assil, and this is Combined Science. So this is IGCSE Cambridge Combined Science, and this is paper 4.1 of November 2022. So let's take a look at the questions and discuss the answers. The first question says, Figure 1.1 shows the structure of a human heart. So this is the human heart from outside. State the name of the part labeled P. Can you see where P is? If you look at the heart, these are the parts of the heart. So can you see where P is? Remember, P is the right atrium. So this is where blood comes in from the body. And then it goes to the right ventricle. Can you see where the right ventricle is? And then it goes out through the pulmonary artery to the lungs. And then it comes back through the pulmonary veins that carry blood from the lungs to the left atrium, and then to the left ventricle, and then it goes out through the aorta to the rest of the body. So please remember this circulation of blood. Now, state the name of the blood vessel that transports blood from the body to the heart. So any blood coming from anywhere in the body will enter the heart through the vena cava. Can you see that? The human heart is part of a double circulation system. Describe the double circulation system in humans. Remember, in humans, the blood goes through the heart twice. So once it goes from the body to the heart to the body. And once it goes again from the heart to the lungs to the heart. So we call this a double circulation. The waist to hip ratio is used to determine whether a person is overweight. The waist to hip ratio is calculated from two measurements using the equations shown. So he's telling you, in order to know if someone is overweight or not, we take the waist measurement over the hip measurement, and this can indicate the degree of obesity. A person has a waist measurement of 80. A hip measurement of 97 centimeters. Calculate the waist to hip ratio of this person and give your answer to two significant figures. So of course he gives me the numbers. I just put it into the equation, the waist over the hip. This comes out to be 0.8247. Please do not forget to do what he asks. He says give your answer to two significant figures, and that means this number cannot be left like this. It has to be 0.82. You should be able to know how to determine the number of significant figures. The 0 before the decimal is not counted, so this is two significant figures. The people of one country are grouped into different categories according to waist to hip ratio. The incidence of coronary heart disease in each group is recorded. So he's comparing the waist to hip ratio to the incidence of coronary heart disease. Describe the relationship between, from the graph, so you're going to look at the graph, the relationship between incidence of coronary heart disease and waist to hip ratio. So obviously in the graph, what we can see is that as the waist to hip ratio increases, the incidence of coronary heart disease increases. Describe how malnutrition may cause coronary heart disease. What in our diet could be causing coronary heart disease? Remember that what is coronary heart disease? It is the blockage of the coronary artery. So this is the artery that is bringing blood to the heart, to the walls of the heart, to the muscles of the heart. If this artery is blocked, and this is usually by deposition of fat, so fat deposits inside the artery, blocks it, this causes coronary heart disease. So what in our diet would lead to that? Increased intake of fats in the diet. So that is a type of malnutrition when you take too much of something. This causes deposition of fat inside the coronary arteries, leading to coronary heart disease. Concentrated aqueous sodium chloride is electrolyzed using inert electrodes as shown. So he has electrolysis of concentrated aqueous sodium chloride. First of all, he's saying describe the chemical tests for hydrogen and for chlorine. He's showing me that when I do electrolysis of concentrated aqueous sodium chloride, I get hydrogen gas and I get chlorine gas. So what is the test for hydrogen gas? Please remember the tests for hydrogen gas. It is insert a lighted splint, it pops or it gives a pop sound. What is the test for chlorine? Insert damp blue litmus paper, it bleaches. Remember, the litmus paper, the color is removed when it is exposed to chlorine gas, so we say it bleaches. The equation for the electrolysis of concentrated aqueous sodium chloride is shown, and he's saying complete the equation by adding the missing state symbols. So, what are the state symbols? For sodium chloride, he's telling me it's an aqueous solution, so I need a state symbol that says AQ. That means that the sodium chloride is dissolved in water. Now, what is the state symbol for water? Remember that water is a liquid, so that is L. Hydrogen is a gas. Chlorine is a gas. What about the sodium hydroxide that is obtained at the end? The sodium hydroxide is dissolved in water, so it is aqueous. State the name of the product that has the formula NaOH. Of course, what is NaOH? You should know that that is sodium hydroxide. 4 statements about the electrolysis of concentrated aqueous sodium chloride are shown in the table. Put a tick in one box in each row to show whether each statement is true or false. Again, what are we doing? We're doing electrolysis of concentrated aqueous sodium chloride. Let's revise this again. Remember, if I have electrolysis of an aqueous solution, that means I have the ions from the solid dissolved there, so that is sodium chloride. Remember that the first one is always positive, the second one is always negative, so it's Na plus Cl minus. But it's a solution, so I also have the ions from water, which are H plus and OH minus. Now, which one goes to the anode? Remember that the anode is the positive, so the negative ions go to the positive. Now I have a choice between chloride and hydroxide at the anode. Which one will react? The one present in larger amounts. So he's telling me I have concentrated aqueous sodium chloride. That means I have more chloride ions, so it is the chloride ions that will react. So the chloride will lose electrons at the anode and become chlorine gas, and what I see is bubbles of green gas. Now, at the cathode, I have a choice between Na plus and H plus. Again, which one will react? It is the one that is lower in electrochemical series or reactivity series. So it is the H plus that reacts, gains electrons, and becomes hydrogen gas. So I should get bubbles of colorless gas at the cathode. So this is what happens when we do electrolysis of concentrated aqueous sodium chloride. Now let's look at each statement now. He's saying hydroxide ions are attracted to the cathode. No, hydroxide ions are negative. They will be attracted to the positive, which is the anode. So this is a false statement. When he says H plus ions gain electrons at the negative, H plus ions gain electrons at the negative, that is actually true. H plus ions come from the water in solution. Yes, that's where it came from. Hydrogen gas is made when OH minus ions lose electrons. Remember, hydrogen gas is made when what? When H plus ions gain electrons. So that statement is false. Okay, then he says a solution of hydrochloric acid is mixed with universal indicator solution. State the color and pH. So remember, these are the colors of universal indicator. And we said this could be a paper in which you compare the color to the chart, or it could be a solution. So in this case, he has the solution in hydrochloric acid. And you should realize that hydrochloric acid is a strong acid, so the universal indicator will turn red, and that is because the pH you could write 1 or 2 or 3. Strong acid has pH 1 or 2 or 3. Remember the rest of these, you're supposed to know that vinegar, lemon juice, ethanoic acid, these are weak acids. They will have pH 4 or 5 or 6, and the color we usually say yellow or orange. If something is neutral, like water or sodium chloride, then it has a pH of 7, and the color of the universal indicator is green. Now, after that, base is usually blue. A weak base, like ammonia, has pH 8, 9, or 10. A strong base, which is something oxide or something hydroxide, would have pH 11, 12, 13, 14. Please know these numbers and these colors. Question 3 says, figure 3.1 shows forces P, Q, R, and S acting on an airplane moving forward along a runway. Use figure 3.1 to complete the sentences. And you're required to write P or Q or R or S. So first of all, he's saying the weight of the airplane. Which of these indicates the weight of the airplane? Remember that the weight is the force due to gravity. So the weight here is Q. It is balanced by force what acting in the opposite direction. Of course, if we say Q is the weight, where is the force acting in the opposite direction? That is S. Now, which force is greater than which force to cause the airplane to accelerate along the runway? So I want the plane to move faster. Can you see the direction of the arrows? So one of them is going to be P and one of them is going to be R. Now, if I want this plane to go forward faster, then P is greater than R. In that case, the airplane accelerates. That means the speed increases, you should know that, along the runway. The mass of the airplane is 120,000 kilograms. Calculate the weight of the airplane. And we should know the gravitational force is 10. Oh, he gives me that the gravitational force is 10. Okay, so the mass he gives me, and he wants the weight. How do we get the weight? You should know that weight is mass times gravitational force. He gives me the mass and he gives me the gravitational force. So this is the weight in newtons. The total area of all the airplane tires in contact with the ground is 0.125 meters squared. Use your answer to B1 to calculate the pressure exerted by the airplane on the ground. So we want to calculate pressure. How do we calculate pressure? Pressure is force over area. Of course, the force is the weight that we have there. So we calculated the weight to be this number. So that is the force over the area that he gives me. That gives me the pressure, and remember that the unit for pressure is Pascal or Newton per meter squared. The engines of the airplane provide a driving force of 1.2 times 10 to the 6 Newton. The airplane moves a distance of 1,500 meters along the runway. Calculate the work done by the engines. So, how do we calculate work? Work is force times distance. He already gives me the force and he gives me the distance. We just multiply them to get the work in joules. Are we following? Okay. The airplane takes off at a speed of 80 meters per second. Calculate kinetic energy of the airplane. How do we calculate kinetic energy of the airplane? Please make sure before you enter the exam that you have memorized these equations. Physics is mostly equations that you need to memorize. What is the equation for kinetic energy? Half mv squared, or half times the mass, and he already gives me the mass previously, times the speed to the power 2, and he says the speed is 80. So multiply all of these together, it gives you the kinetic energy in joules. Suggest a reason for the difference between your answers in B3 and B4. So we calculated work and we calculated energy. The work was 1.8 times 10 to the 9. The kinetic energy that was used is the 3.84 times 10 to the 8. So why is work more? Why is it doing more work than the energy it's actually needing? This is because some of the work is used to overcome air resistance or friction. Starch is broken down by amylase into smaller molecules. State the type of carbohydrate molecules produced when amylase breaks down starch. Remember, starch is what we call a complex carbohydrate. Now, amylase is an enzyme that breaks down the starch into maltose. Maltose is 2 units of glucose, so we're basically breaking down the long chain of glucose units into shorter chains. Now, these shorter chains are referred to as simple sugars. Figure 4.1 shows the effect of temperature on amylase activity. Explain the effect of temperature on amylase activity between 25 and 35. Where is 25 and 35? Can you see this is a graph of what? It's a graph of time. So from 25 to 35, the reaction took less time. Less time means faster or slower? Faster. So as we increase the temperature from 25 degrees Celsius to 35 degrees Celsius, the enzyme reaction is faster. You should know that that is because as temperature increases, the particles gain more kinetic energy, move faster, collide more frequently or more collisions per second. So the rate increases and time decreases. Remember, he's saying explain the effect. So you have to mention what is the effect and you have to explain why. So please don't forget to say that the rate increases. That's the effect. Now, the rate increases. How did we know the rate increases? Because the time decreases. Now, why does the rate increase? Because the particles gain more kinetic energy, move faster, so they collide more frequently. Explain why amylase does not break down protein molecules. Remember that for any enzyme, we say enzymes are specific. That means each enzyme acts only on a specific substance or a specific substrate. So amylase, for example, will act on starch, but it will not act on anything else. This is because the enzymes are specific for specific substrates. This is because each enzyme has an active site with a shape complementary to its substrate. So the amylase has active site, a part of the molecule that has a shape complementary to that of starch molecules. Nothing else will fit into this active site. Starch is used for storage in plants. Carbon in starch is returned to the atmosphere as part of the carbon cycle, and the diagram I have here is a simplified diagram of the carbon cycle. State two processes in the carbon cycle that return carbon to the atmosphere. Let's take a look at the carbon cycle. You should be able to know each of these arrows represents what. So can you see arrow A? Arrow A represents what? When plants take carbon dioxide from the air, this is which process? Plants taking carbon dioxide from the air, that is photosynthesis. So that arrow represents photosynthesis. Now, the arrow going back to carbon dioxide in the air. So when plants give up carbon dioxide to the air, that is respiration. Respiration can occur in plants and in animals. Now, what is D? D is when dead organisms give up carbon dioxide in the air. This is a process of decomposition. When the bacteria break up the dead organisms, it gives up carbon dioxide into the air. That is decomposition. Now, let's look at E. Can you see E? E is when carbohydrates in plants go to carbohydrates in animals. Of course, this is a process in which the animals feed on the plant, so that is nutrition. Now, where is F? When dead organisms change into fossil fuel, this is called fossilization. And then when the fossil fuels, what process will change the fossil fuel to carbon dioxide in the air? Of course, this is when we do combustion. Burning of the fossil fuel will give up carbon dioxide to the air. So the question said, state two processes that return carbon to the atmosphere. So which of these processes take back carbon dioxide into the air? Actually, you can have combustion, respiration, decomposition. The only process that takes carbon dioxide from the air is photosynthesis. Then he's asking, state the process in the carbon cycle that traps carbon for millions of years. So which of these processes traps carbon for millions of years? That is when we make it into fossil fuel. So that is the process of fossilization. Plants are producers in a food web. This figure shows a food web. Use figure 4.2 to explain why the snake is both secondary and tertiary consumer. Can you see where the snake is? Okay. The snake can feed in two food chains. It can either feed from grass to insect to snake, or grass to insect to toad to snake. Can you see that? So if it goes from grass to insect to snake, then the grass is the producer, the insect is the primary consumer, and in that case, the snake is secondary consumer. But if we go the other way, grass to insect to toad to snake, then in that case, the snake is a tertiary consumer. So when the snake eats insect that eats grass, it is secondary consumer. When it eats the toad, then it is a tertiary consumer. The energy level diagram for the combustion of hydrogen is shown. State which arrow represents the overall energy change for the reaction. So which arrow here is delta H? Remember, delta H is the enthalpy change or the energy change of the reaction. So which arrow represents delta H? Remember, it's the arrow going from reactants to product. So that in this case, it is arrow C. Complete the table to describe the changes represented by arrow A and arrow B. Where is arrow A and arrow B? Okay, what is arrow A? If I were to ask what is arrow A represents the energy of activation. So the energy of activation is the energy needed to start a reaction. So we're breaking the bonds in hydrogen and in oxygen. And when we break bonds, we need to take in energy in order to break the bonds. Now, where is arrow B? Arrow B is going from the top of the activation energy to the products. So this is when the complex formed at the top, when we gain activation energy, to the reactants at the bottom, and this is obviously an exothermic reaction. So in this case, we are forming the bonds in the water, and when we form bonds, this gives out energy. Remember, bond breaking is endo. To break a bond, energy needs to be taken in. But bond formation is exothermic. When bonds form in the products, they give out energy. Some cars use hydrogen as a fuel. Some cars use diesel oil as a fuel. Diesel contains mainly alkanes. Give one similarity and one difference between the products of combustion of hydrogen and complete combustion of alkanes. Remember, when you burn hydrogen, what do you get? Burning of anything means reaction with oxygen. And when we burn hydrogen, the only product I have is water. But when I burn any alkane, so this is, for example, butane. If I burn any alkane, complete combustion, that means reaction with lots of oxygen, this gives what? This gives carbon dioxide plus water. So the similarity between these two is that they both produce water. But the difference is the hydrogen produces only water, but the alkanes form carbon dioxide in addition to the water. Use your answer to suggest why diesel cars are considered more harmful to the environment. Of course, they produce carbon dioxide. Remember that carbon dioxide is one of the greenhouse gases that traps the heat of the sun. So the carbon dioxide that is produced contributes to climate change. Table 5.2 shows information about melting points and boiling points of hydrogen and diesel. So you can see that hydrogen, the boiling point is very low, hydrogen is a gas. But diesel, the boiling point is high, so diesel is a liquid. Use the information to suggest why hydrogen is more difficult to store than diesel. Why is that? Of course, if hydrogen is a gas, then gas particles take up more space, but diesel is a liquid. In liquid, the particles are nearer to each other, so more particles can be put in the same volume. This question shows a hair dryer. The hair dryer contains an electric motor to blow air and a heater to heat the air, and the plug contains a fuse. Okay, now he's saying this figure shows the circuit diagram for the hair dryer. So he has a power supply with 240 voltage, the fuse, a switch, a heater, and a motor. And he's saying the electric motor has a power rating of 60 watts. So the motor has 60 watts. The heater has 2300 watts. Now show that the current in the fuse is 9.8 amperes. So if I have the power in each one, I can get the current in each one. So power is current times voltage. So if I want the current is the power over the voltage. So if I look at the electric motor, the current going through the electric motor is 60 watt over the 240, which is the voltage, and that gives me a current of 0.25 amperes. Now, the current in the heater is 2300 over 240, that is 9.58 amperes. Remember that the heater and the motor are connected in parallel. So the current that was originally coming from the power supply was divided between current going to heater and current going to motor. So the total of them, total of the one going to the heater and the one going to the motor, that would be the total current going through the fuse. So this gives me a current of 9.8 amperes. Discuss whether 10 ampere is an appropriate reading for the fuse. So I need 9.8 amperes to go through the electric circuit. If my fuse is 10, you can say that 10 is higher than the current in the circuit, so the rating is appropriate, and that means that if 9.8 amperes goes through it, the fuse will not blow under normal conditions. But actually, you have another answer also. You can also say that the 10 is very close to 9.8, so any slight increase in the current would cause the fuse to blow. So either one would be correct. Then he says figure 6.3 shows a different hair dryer that has two switches. Now listen, when switch 1 is on, can you see which one is switch 1? Switch 1 is on and switch 2 is on, both of them are on, the hair dryer blows out heated air. And that means if both the switches are on, then both heater and motor are working. Then when switch 1 is on but switch 2 is off, the hair dryer blows out unheated air. That means if I close switch 2, the heater does not work. When switch 1 is off, both motor and heater are off. So switch 1 controls both heater and motor. Switch 2 controls only the heater. Now, on the figure, complete the circuit diagram for the hair dryer by adding switch 1 and switch 2 in the correct position. So we want switch 1 to control them both, but switch 2 controls only the heater. So when you draw the diagram, it should look something like this. The switch 1 is outside in the circuit so that if it's closed, it will control both. But switch 2 is only with the heater, and that means if it is closed, then or if it is off, then the heater does not work. Figure 7.1 is a diagram showing a fetus developing inside the female reproductive system. On figure 7.1, draw a label line and the letter O to identify one ovary. Where is the ovary? The ovary is that small circle on both sides, so you can label this one or the other one. That is the ovary. Remember, the ovary is the one that produces eggs, so it produces the female cell and it produces the female hormone. Complete the sentence about the placenta using one word from the list in each gap. Okay, the placenta. Remember, the placenta is the one that provides a barrier to prevent what from reaching the fetus. The placenta is the attachment between the fetus and the mother. It will prevent toxins from reaching the fetus, but it will allow excretory products to pass. He's saying to pass from the fetus to the mother. What passes from the fetus to the mother? These are the excretory products of the fetus. A pregnant female takes vitamin D to supplement her diet. Explain why vitamin D is needed during pregnancy. So we need to talk about the fact that she's pregnant. So in general, why do we need vitamin D? We need it for absorption of calcium. So if we do not take vitamin D, then we have soft bones and teeth and bow legs. These are the deficiency symptoms. So why would a pregnant female need more vitamin D? This is because the vitamin D is needed by the fetus for absorption of calcium for development of its bones and teeth. Pregnant females are advised not to smoke tobacco. Tobacco smoke contains nicotine and tar. Describe the effects of nicotine and tar on the body. What is bad about nicotine? It is addictive. You know what addictive means? That means the body gets used to it and needs more and more of it. So that is the bad effect of nicotine. Tar, we say tar causes lung cancer. It also affects the ciliated cells and the goblet cells in the respiratory system. It could lead to emphysema, um, chronic pulmonary diseases, and so on. Period 3 of the periodic table is shown in the figure. Identify two metals and two non-metals in this period. Remember, he's going from group 1, 2, 3, 4, 5, 6, 7, and 8. You should know that the ones on the left, group 1, 2, and 3, are metals. So for metals, you can either say sodium or magnesium or aluminium. Groups 1, 2, and 3 are metals on the left side of the periodic table. And of course, everything in between, which are transition metals. Then starting from group 4 to group 8, these are non-metals. So he wants non-metals. You can either write silicon, phosphorus, sulfur, chlorine, argon. A sodium atom forms a sodium ion. A chlorine atom forms a chloride ion. Explain why the ions formed by these atoms have different charges. Why do we say Na plus, Cl minus? Remember that sodium is in group 1. It has 1 electron in its outermost shell. In order to form an ion, it should lose that outermost electron. And that means the number of protons will be more than the number of electrons, so it has an extra positive charge. But chlorine has 7 electrons in its outermost shell. It needs 1 in order to have a full outer shell. So it gains 1 electron. That means it has an extra negative charge. So the sodium atom loses the outermost electron, so becomes Na plus. The chlorine atom has 7 electrons in its outer shell. It gains 1 more to have a full outer shell. Sodium and chlorine react together to form sodium chloride and ionic solid. Figure 8.2 shows the arrangement of ions in solid sodium chloride. 2 of the ions have been labeled. Complete by labeling the other ions. Remember, when we look at the structure of an ionic solid, it is made up of what? It is made up of a 3-dimensional crystal lattice with alternating positive and negative ions. So you should have positive, negative, and so on. So you have alternating positive and negative ions. Explain why ionic solids have high melting point. Of course, an ionic solid that has many positive and negative ions will have strong electrostatic attraction forces between the oppositely charged ions, and this needs a lot of energy to be broken. Remember, this is how we explain why ionic solids have high melting point. State the name of an element in the same group of the periodic table as sodium that is more reactive than sodium. Sodium is in group 1. How does the reactivity in group 1 increase? They increase going down the group so that the one at the bottom is more reactive than the one above it. So he's saying give an element that is more reactive than sodium. That is any element below sodium. So you can say either potassium or rubidium or cesium, or you could also include francium, which is at the end. State the name of an element in the same group of the periodic table as chlorine that is more reactive than chlorine. Now chlorine is in group 7. And you should remember that in group 7, the reactivity is the opposite of group 1. So in group 1, we said the one below is more reactive, but in group 7, the one above is more reactive. So which one is more reactive than chlorine? Fluorine. That's the only one in the group that is more reactive than chlorine. A radar system in an airport uses microwaves to find and track an airplane in the sky. Figure 9.1 shows an incomplete electromagnetic spectrum. Write microwaves in the correct place. Again, what is the electromagnetic spectrum? You should realize that sometimes it is written from left to right and sometimes from right to left. So remember that if we have gamma rays, then X-rays, then ultraviolet, then the next one is visible, the next one is infrared, microwaves will be just before radio waves. The radar system makes a regular beeping sound. When the airplane gets close to the airport, the beeping sound increases in volume and in pitch. The figure shows the waveform of the beeping sound when the airplane is far and when the airplane is close to the airport. So he's saying it will increase in volume. Why does it increase in volume? Why does it become louder? Because the amplitude is higher, or it has increased amplitude. Remember that the height of the wave or the amplitude has to do with whether the sound is loud or quiet. The pitch has to do with what? It has to do with the number of waves or the frequency of the waves. So obviously when it comes close to the airport, it has higher frequency, and that means higher pitch. Write one word in each gap to complete the sentences about waves. For what type of wave the direction of vibration is at right angles to the direction of travel of the wave? Remember, we have two types of waves. We have transverse and longitudinal. In which one is the direction of vibration perpendicular to the direction of travel? So that is, of course, in the transverse wave. In the longitudinal wave, the direction of vibration is parallel to the direction of travel of the wave. Then he says an airplane is flying in bright sunlight. It is warmed by the electromagnetic radiation from the sun. State the speed at which the electromagnetic radiation travels from the sun. So the speed of the radiation is 3.0 times 10 to the 8 meter per second. Please remember that number. The distance of the airplane from the sun is this. Use your answer to calculate the time taken for the electromagnetic radiation to reach the airplane from the sun. So he gives me the speed, the distance, and we want the time. You should know that speed is distance over time, and that means time is distance over speed. You put the distance he gives me over the speed, that is 500 seconds. Suggest how painting the airplane in shiny white paint helps to keep the airplane cool. What is about white paint or black paint? You have to remember that. A white shirt, for example, would reflect the light that comes from the sun, while a black one absorbs the light from the sun. So if we paint the airplane white, then the white surface reflects the heat from the sun, and this keeps the airplane cool. And that was the last question in this paper. Please study all of this. Make sure that you know all the equations, you understand the topics. I hope this was useful to you. Please share the video. Keep listening. Thank you.